elucidation or deduction of the shape of covalent molecules or ions with one or more lone pairs of electrons. So before doing this, the first work what we have to check is if we have bond pair 2, lone pair 1, the actual shape will be, I'm just making this chart more concise. The actual shape will be bent or V-shaped. We'll use that chart only. Bond pair 3, lone pair 1. It will be trigonal pyramid. Bond pair 2, lone pair 2. It is also bent or V-shaped. The elucidation is there already in the previous video. Bond pair 4, lone pair 1. It is seesaw. Bond pair 3, lone pair 2. It is T-shaped. Bond pair 2, lone pair 3 is linear. Bond pair 5, lone pair 1 is square pyramid. Bond pair 4, lone pair 2 is square planar. So using this, let us solve this one. The first question given is tin chloride SnCl2. The total valence electron here we will find for tin. It is in group 14. So total valence electron 4 plus for each chlorine it is 7. Therefore it comes equal to 18. Now what we will do, since either tin or chlorine both will go for octet, we will divide this by 8. Now on division, whatever quotient we will get, this quotient is equal to bond pair and remainder by 2 is lone pair. Then after getting the bond pair and lone pair, we will see the chart and we'll get the shape of the molecule. So what we were doing, we were dividing 18, the quotient is 2. Therefore the bond pair is 2. Remainder is also equal to 2. The lone pair is remainder by 2, or that is equal to 1. Now then SnCl2 comes with bond pair 2, lone pair 1. That means it comes with the first one, bent. Bond pair 2, lone pair 1 comes with the bent or V-shaped. So this is the way how we are actually calculating the shape of the molecule. Now coming to the next one, suppose we have XeF2. The total valence electron, what we will calculate is, for xenon it is a noble gas 8 plus fluorine will be 2 into 7. That comes equal to 8 plus 14, that is 22. Now we'll divide it by 8. We will get 2 bond pair, 8 2s are 16 and 6 will be remainder, lone pair will be remainder by 2, that means 6 by 2, or that is equal to 3. So this XeF2 is a molecule which will have 2 bond pair and 3 lone pair. The arrangement will be Xe over here, 2 bond pair, 3 lone pair is in fact with the trigonal bipyramid structure, and as we know, this electron pairs will be placed in the plane and the fluorine will be above and below the plane. Then finally it comes to the linear shape with a bond angle of 180. Just we have 2 bond pair, 3 lone pair, the shape will be linear. If you see some other example, suppose Suppose we have BRF5. The total valence electron what we will calculate is 7 for bromine plus 7 into 5. So that comes equal to 35 plus 7 means 42. When we divide this 42 by 8, we will get 5 bond pair. Quotient is 8 5s are 40 and 2 remainder means remainder by 2 is lone pair, so we will have 1 lone pair. 5 bond pair, 1 lone pair stands for square pyramid as per the chart. And if we want to make the structure, it will be like this. It's an imaginary square. The one fluorine is above the plane and below the plane there will be lone pair of electron. That's how the square pyramid looks like. So similarly, you need to solve this SO2 ClF3 ozone I3 minus XeOF4 XeF4 and SF4. Kindly solve all this and then accordingly we will find the different examples also. Now let us see the molecule NF3, nitrogen trifluoride. The total valence electron comes equal to, now for nitrogen 5 and 3 into 7. So it is 5 plus 21 comes equal to 26. 26 means we have the bond pair. 26 divided by 8, the quotient comes equal to 3. 3 8s are 24. And lone pair will be, since we have remainder 2, so lone pair will be reminded by 2, or that is equal to 1. 3 bond pair, 1 lone pair is trigonal pyramid. Looks like this is nitrogen, these are the fluorine, and this will be the lone pair. Now, when we need to find NH3, this is also true that this will have the same shape. In H3 we have seen earlier also this square pyramid, trigonal pyramid shape, but now it is true that it is also having the trigonal pyramid shape, but how to deduce this? The total valence electron in NH3 is nitrogen 5. For each hydrogen it is 3. So total valence electron comes equal to 8. Now we can't divide it by 8 because hydrogen only has to form a doublet. So how to calculate this? For doublet also we have 2 electrons and for lone pairs also 2 electrons. So this cannot be obtained by dividing it by 2, so that we will get the 4 bond pairs and it won't work like this. So how to solve this? Since it has 3 hydrogen and each hydrogen is forming a single bond only, so what we will write, for one hydrogen the shared electrons pair is 1. So for 3 hydrogen the shared electron pair will be, of course, 3. Since we have only 3 hydrogen, the shared electron pair will be 3, or thereby the shared electron pair means bond pair will be 3. So automatically the lone pair will be 1, as the total valence electron 4 8 means it has 4 electron pair. Since The 3 bond pair has already come out, then the out of 4, 1 will be lone pair. Accordingly, we are getting the shape will be trigonal pyramid. Similarly, when it will be water, how to calculate H2O? The total valence electron we will find 2 into 1 plus 6. 1 for hydrogen and 6 for oxygen. It will again come as 8. Now again, it's a law of doublet. So what we will do again, for 1 hydrogen, the shared pair is 1. Since 2 hydrogen are there, therefore for 2 hydrogen, the shared pair will be, since total valence electron is 8, therefore total electron pair is 4. If total electron pair is 4 and out of this the shared pair or bond pair is equal to 2, consequently the lone pair will also be equal to 2. So 2 bond pair, 2 lone pair comes for bent or V shape. Bent or V-shaped means it comes like this. This is oxygen, this 2 are hydrogen, this is the lone pair, and this is another lone pair. However, it comes as this only, the bent or V-shaped. Now here, I'd like to tell one very important point, that in methane, in ammonia and in water, the central atom, carbon, nitrogen and oxygen respectively, all these are sp3 hybridized, but the bond angles will be different. Methane has a bond angle of 109.5. Ammonia has a bond angle of 107 degree and water has a bond angle of 104.5. Why it happens? In methane, we have all the 4 as bond pair, therefore there is no question of different type of electron pair repulsion. It is only the bond pair repulsion, and absence of any lone pair does not distort the geometry. It has a definite bond angle as expected from sp3 hybridization is 109.5. In ammonia, as we have seen, we have 1 lone pair and the 2 types of electron pair repulsion is observed. One is lone pair bond pair repulsion, another is bond pair repulsion. Since the lone pair bond pair repulsion is much more prominent, so therefore this lone pair tries to take more space and keeping the bond pairs close together. So in case the bond pairs are close together, the bond angle is decreased by a factor of 2.5, and 109.5 minus 2.5 comes equal to 107 degree. When water is there, we have 2 lone pairs. Even in sp3 hybridization, we have 2 lone pairs. So for 1 lone pair, the bond angle is decreasing by 2.5. Therefore, for 2 lone pairs, bond angle should decrease by 2 into 2.5 means 5. Therefore, it is 109.5 minus 5 is equal to 104.5. That's why even the hybridization of the central atoms are same, but the geometry, the shape and the bond angles of all 3 molecules are different, and hence the bond lengths are also differing. Now getting the hybridization of carbon. As carbon is only 1s2, 2s2, 2p2 and it has non-availability of any d orbital, therefore it cannot extend its valency beyond 4. So it can make only 4 bonds, and out of this, it can make only 3 bonds to satisfy its valency maximum. 3 bonds with the same, like triple bond, it can also make double bond, then other 2 would be there, and it can make simple single bond. So in this case, when it is forming multiple bonds, it's obvious that there will be 2 pi bonds and 1 sigma bond. In case of a double bond, it will be 1 sigma and 1 pi, and in case of all single bonds, this all 4 will be the sigma bonds, right? So how we will justify? We know that pi bond is formed by the px or py overlapping. So out of this 3 p orbitals, if there will be one pi bond, then at least px or py will leave to vacant out of hybridization. Then in that case it would be only sp2 hybridization. Similarly, if it has to form 2 pi bonds, then we have to keep both px and py aside out of the hybridization. Then out of this s and this 3p orbital, this will be for their pi bond, this will also be for pi bond. Then we are having only sp hybridization option. So just in a simple way, if carbon, all these are sigma bonds, all sigma bonds we are having, then it will be simply sp3 hybridization. Then no pi bond means all 4 can be involved. One pi bond, only one pi bond, then it will be sp2 hybridization, and 2 pi bonds means it will be sp hybridization. These 2 pi bonds can be in between same pair, can be with different pairs also. For example, if we are considering ethyne or acetylene molecule, this has 2 pi bonds in between this carbon as well as this carbon. So both the carbon will be sp hybridized. In case we have CH2 double bond CH2, a single pi bond is there, it will be sp2 hybridized, this will also be sp2 hybridized. In case we have CH3 CH double bond CH2, since one pi bond is there, this will be sp2 hybridized, this will also be sp2 hybridized, and all sigma bonds means this will be sp3 hybridized. Now consider the carbon dioxide molecule. In CO2, we have this carbon, one pi bond over here, another pi bond over here. As a whole, this carbon has 2 pi bonds. Therefore, it is again sp hybridized. And as carbon dioxide is sp hybridized, it's obvious that it will be a linear molecule. In the linear molecule, as I discussed earlier also, the bond moments are present, but they are cancelling each other because of its linearity. All these are the x components only, and they are cancelling each other. But in case of water, the dipole moment or bond moment is directed towards oxygen, more electronegative. So consequently, if this is being resolved, we will have the resolution as this x component and y component. And in case this one is resolved, we will have this as x component, this as y component. So the x component or horizontal components are cancelled by each other, but the vertical components are being enforced or added, and that makes the water as a polar solvent. This is the reason why water acts as the universal solvent, but carbon dioxide cannot, because this water can dissolve ionic molecules, can has a large charge separation capacity, can dissolve the polar covalent molecule, and this water can not only dissolve certain selective molecules which are having just the London dispersion forces. That means there is no scope or very little scope of ionization or development of even temporary dipole. So that is the reason why most of this compounds are soluble in water due to its high dielectric constants.